Yes.
Okay, so if you have 10 to the third bacteria per milliliter,
Okay, so setting up the problem. So you said 10 to the third bacteria
per
milliliter, which isn't a lot of bacteria.
and you place 1 milliliter in 9 milliliters of dilution.
So 1 ml goes into a tube that already has 9 mLs in it.
What is the concentration of bacteria post-dilution?
So that's asking what's the concentration in there. So what you have done conceptually here is you've taken a certain amount of bacteria, the amount that were in this 1 ml, and you know how much is in that 1 ml because that's the units here, and you have increased that volume tenfold. And that has the effect of decreasing the concentration tenfold. And so I mean, that one's quite simple. It's really, you just take 10 to the third, you divide by 10. And doing that with exponents, you put a 10 to the 1 there, and what that means is it's 10 to the third minus 1, which is equal to 10 to the 2 bacteria per ml in here. Now, I was told last year that if you want people to really understand dilution problems, you don't do it using bacteria, you do it using proof. And so if you had a 200 proof, absolute whatever, alcohol, and you took 1 part of it and put it into 9 parts of water, what would the proof be? It would be 20, because it's tenfold smaller. If you took 80 proof and you mixed it with, I don't know, rum and Coke, 80 proof rum and you mixed it with 50-50 with Coke, what would the proof be? It would be 40, because it's 1 part rum, which has the 80 proof, and 1 part Coke, and so you've taken basically whatever the amount of alcohol was in that 1/2 of the rum, and now it's in a volume that's twice as big, so you simply put 2 underneath it, and it's half of it. That is what dilutions is. It's all about fractions, and in microbiology we use a lot of exponents, but it's all about fractions. What? With the alcohol. Yes.
Can you explain the tenfold? Like how you get that?
Oh, well, okay, yeah. I mean, that is a step that I was implicit rather than being explicit about. But it's easy. It is that number there plus that number there. And that gives you a total final volume of 10 mLs.
Except for the last one.
So it's this number of bacteria because you took 1 ml, and this is the per ml. If you had taken 1/10 of an ml, it wouldn't be 10 to the 3, it would be 1/10 of 10 to the 3. It would be 1/10 as many bacteria as you took. But it's the number of bacteria that you're putting into this tube divided by the final volume seen in that tube. And the final volume in this case is, well, in any case, you take the amount you put in, the amount that's in there, and that's the volume. It's actually very easy stuff once you get the hang of it, and I find it much easier to get the hang of it if you draw little pictures.